Good morning. Morning, folks. We'll get started in just a couple of minutes. Wait for maybe a few more people to show up. Let's see if we can maybe get 10 people. And once 10 people are here, then we'll get started. So I'll be right back. I am just going to make myself a cup of coffee. So I'll see you in maybe 3 minutes. And you're in good hands. Don't worry. I've got my my trusty little goosey poo right over here. I don't know if you can see her. Hi, sweetheart. Say hi to everybody. Say hi. Say hi. Say hi. She's just purring. She's purring. She's happy. Yeah. Okay, she's gonna stay here with you guys and play with my iPad, lie down on my keyboard, do all sorts of funny things, and I'll be right back. Okay, look at that. We got 11 people. Goose is still here, so that's good. Okay, so let's jump into it. So the past couple weeks we've been looking at systems of equations, right? I think that we kind of took a few steps back to talk about systems of linear equations. And I think we did a word problem on Friday, and we've been looking at different ways of solving these things. So far, the way we've been looking at it is through graphing. So we've been looking at being given two equations and drawing their graph and associating the intersection points with a solution to that system. So that's what we've been doing. Today what we're going to do is we are going to continue in this fashion, except we're going to sort of take it to the next level. We're going to start looking at how algebra plays into this. So I've got a few examples that I'd like to do with you, and I'd also like to share the sort of the thought process that goes on behind these and some of the reasons why we do what we do algebraically. But before I jump into that, I do have to talk a little bit about our latest assignment. I posted it just this morning. It's due on Friday at midnight, so you have the whole week to do it. The assignment is on radicals, and it's just on radicals. So I know I said that I would draw on previous topics, but there was just enough. There's just enough different topics within radicals that that I thought we could just have the entire assignment just all on radicals. So form for the solutions, I'm just going to be giving you, I'm just going to be accepting like photographs or scans of your work. So however you'd like to do that is up to you. But if there's an assignment that's been submitted that's illegible, like if I can't read it properly, then I'll send it back and I'll ask you to resubmit it. Won't be a big deal, but I really don't want to have to be fiddling around with like rotating images. It sounds like it's not that much work, but when you have several dozens of assignments and you're kind of in the middle of marking, and then all of a sudden you've got this crooked one, you have to stop what you're doing, and it ends up costing a lot of time. So if there is an assignment that makes it more complicated for me to mark, I will politely ask you to resubmit it. So yeah, just bear that in mind. And if you're curious about how I prefer to submit it, it doesn't hurt to ask. Like, I'm not going to be surprised or unimpressed or something if you ask me if this is acceptable or something like that. So yeah, I think I made a suggestion on there to use some software like Google Docs. You can always use Google Docs to import some images and make sure that they're aligned properly. Like the worst thing, and it sounds like it wouldn't be that big a deal, but when a photo is rotated 90 degrees, because usually what happens is you end up taking a picture like this, right, of your work, and the accelerometer in your phone doesn't know if you should be in portrait or landscape mode. So a lot of these photos end up being rotated 90 degrees, which like I said, it does cause quite a bit more work for me. So I'd really like it if we could just all spend maybe an extra 3 or 4 minutes just making sure that your work is legible and easy for me to mark. Okay, now let's just jump right into it. So today what we're going to talk about is we're going to be talking about using algebra. We're going to talk about using algebra. Now hold on just one second. I think last week oh shoot, okay, what was Friday was the 24th. Yeah, I think last week I said I would give you some extra homework. Oh geez. Okay, give me 1 second here. It looks like I forgot to update the website over the weekend. That's a little frustrating. Okay, so looks like I didn't give you the homework I promised I would have. Okay, give me 2 seconds and I will just post it right now. I'll just copy this. Ba-ba-dum. Sorry guys, I thought that I had updated the website. I had every intention of doing that. So I've updated it now. So now there's a little bit of work on number systems, in particular systems of linear equations. So so yeah, you can check that now. Gosh, I'm really sorry about that. I just wanted to double check that I had submitted it, and the thing about this website is that you can make changes on it, but if you don't hit publish, then it doesn't show up. So I'm really sorry about that. Anyway, so today what we're going to talk about is we're going to talk about using algebra to solve systems of equations. Systems of equations. Okay? So this is what we're going to talk about today, is using algebra to solve systems of equations. So what I wanted to start off with is just some background, okay? So we're going to start off with a little bit of background, and the background is just going to talk about why we do what we do, okay? So, I mean, first what I'll do is I'll tell you what the procedure is, and then I'll tell you why we do what we do. So the procedure looks like this. So the procedure is the following. So, so given two equations, in each equation, what we need to do is solve for y. Okay, so we're going to solve for y in each equation. Now, the second step is to set each side of the equation, that is not y, equal to the other. Okay, so what that means is, I'll just give you a quick example. So if I've gone ahead and I've solved for y in both equations, maybe I've got something that looks like this, like y equals 3x minus 1, and the other one is y equals x squared minus 8x plus 7. Well, what we would do is we would take this portion of the equation and set it equal to this portion of the equation, okay? So we would say, for the second part of the procedure, that 3x minus 1 is equal to x squared minus 8x plus 7. Okay, so that's the next part of the procedure. So the procedure is well, there's three steps. So this is the first step right here. The second step is right here, and then the final step, 3, is to solve for x. So the third step is to solve for x. Okay, so that's our procedure. So let's talk about why this works and what it is we're actually doing here. Because I can just give you the procedure and that would be great, and we could carry on with it and that would be fine. But I think it might help if you understand what we're doing and why it works. So let's just jump right on into it. So if I give you two equations, so if you're given given two equations and you're asked to find a solution that satisfies, so if you're asked to find a solution that satisfies both equations, we are looking for any intersections on the two graphs of the equations, right? And we've seen this. In fact, this is how we've been solving equations for the past week, right? So, just to give you a little visual example, if I've got, maybe one of them is a quadratic, and maybe the other one is a linear equation like this, then the intersection points, these are the solutions. So these are the solutions, right? And maybe there are more than one solution. Maybe there are 0 solutions, right? But any of those intersection points, they must be the solution to our system, okay? So, translating this into algebra, like how is an intersection, how is the intersection of two graphs related to our procedure? Okay? Well, it works like this. So, if two graphs have an intersection, then the intersection point, or the point of intersection, if you will. So the intersection point represents a position where the x and y values in both equations are the same. Okay? So, like in this position right here, the x position and the y position of both the parabola and the linear equation are the same. So what our procedure is doing, so in our procedure, we are isolating y to try to determine the y value of our intersection. Once we set them equal, we solve for x. Okay, so just to give you kind of another visual example, so what I'll try to sort of illustrate that last paragraph and what I mean by that. So let's say that we have a nice little Cartesian graph like this, and I've got one equation like this, and maybe the other equation is also linear. So maybe I've got two linear equations like this, and here they are. They're got nice little arrows. So really what we're doing is I'm going to solve each equation for y, and what that really looks like is, well, I'm gonna have like you can kind of think of me as like scanning different values of y and seeing if any of them intersect, and then all of a sudden, boom, I've got one that intersects, right? That's where we're saying, okay, these two y values are exactly the same, right? Our y value in one equation is equal to the y value in the other equation. So we're taking, like, where is it? So I'm saying that this y is equal to this y, therefore this thing must be equal to this thing, right? So if I have one equation, then that must also be equal to the other one, right? So now we have to solve for x, which is the other variable. So we're basically assuming y is equal. So that the way the procedure is working is that we assume y values, the y values are equal, and then solve for x. Okay, so then basically you would say, okay, so here we've got some y values that are equal, and okay, well then now what's the x value? And then you solve for the x value. And there you're kind of like, you can think of it as kind of like a crosshair, right? So you're first looking for your y value. Oh, there's my y value. So somewhere at this height, we have an intersection, and then we solve for x, and we get the exact coordinate of the intersection to be this point right here. Okay, so let's do a couple examples and see this in action. And I hope the explanation was at least a little bit revealing about how this works and why it works. Now, where did my examples go? Okay, here we go. So let's solve this example. And I don't think we've done, let me just make sure we haven't done this example already. Okay, did we do this one? Square minus 5x minus 1. Just want to make sure that we haven't done this example. I don't think we have. Yeah. Oh, is this it? No. Oh no. Okay. Okay. So we're gonna solve this equation using algebra. Okay. So this is our first big example. So EG. Okay. So solve this system using algebra. Okay, I'm going to solve the system using algebra. So I have this this guy right here. Let me zoom in just a wee bit. That's better. Okay, so I've got this guy. Y equals x squared. Y equals x squared minus 3x minus 4. And I've got this guy here. 2x minus y equals 4. 2x minus y equals 4. Okay, so my first step, step 1, is to solve for y. Okay, so I'm going to solve each equation for y. Looks like this first one already is done, so I'll just rewrite it. I've got y equals x squared minus 3x minus 4. Okay, and I'll give myself a little check mark because that's already solved for y, right? Because y is by itself. I've isolated y. Okay, so y is all by itself. Now let's solve the other one. I'll rewrite it. I've got 2x minus y equals 4. And, well, I'll move y to the other side. I'll move the 4 to the other side. So I have 2x minus 4 equals y. Or in other words, I want the y on the left. So I'm going to say that y is equal to 2x minus 4. And I'll give myself a check mark because y is all by itself. Great. Now we set these two things equal to each other. So we've solved for y, and we're saying, okay, well now we're going to assume that there's a point on both graphs that share the same y value. Now let's see if we can find one that shares the same x value, right? So we're kind of moving up and down. We've said, okay, well, let's assume that the y's are equal. Now let's see if we can find one where the x's are equal. So if the y's are equal, well, then this y would be equal to that y, right? So that means that these sides of the equations would also have to be equal to each other. Now keep in mind, we've seen many situations with quadratics and radicals where you have either multiple solutions or zero solutions, right? So just because we're setting up this equation doesn't mean that there will be a solution. There might be a solution. There might be multiple solutions. There might be one solution, right? And in some cases, we may see that there are infinitely many solutions. So basically, that would happen when like x's cancel out, and you would have maybe something like 4 equals 4. And if you ever have a situation like that, it means that you have an infinite number of solutions because it doesn't matter what x is equal to, the equation holds true. So x could be anything. Anyways, maybe I'm going a little too fast right now. Let's just finish this problem, okay? So I'm gonna set the equations equal to each other. So I've got x squared. Oops, I'll go back to blue here. I've got x squared, and maybe what I'll do is in green I'll write it what the the procedure is. So set equations equal to one another. So the y is equal to y, so that means the other side of the equation is equal to the other side of the equation. And we get x squared minus 3x minus 4 is equal to 2x minus 4. Okay? And we solve this. So that's our third part of the procedure, is to solve the above equation. Okay, so let's go ahead and do that. Well, I'm going to rewrite it again down here, and I'll give myself a little more room to work with. So 3x minus 4 equals 2x minus 4. And okay, let's jump right into this one. So I'm gonna add 4 to both sides, effectively canceling out this minus 4. So I'm gonna do that. And I'm also gonna take this 2x and subtract it from both sides, effectively moving it to that side. So I have x squared minus, well, negative 3 minus 2 is negative 5. We've got x squared minus 5x, and then those 4's canceled out, so this is all equal to 0, right? Let me just move this over just a wee bit. That's better. Okay, so I've got x squared minus 5x equals 0, and well, this shouldn't be too hard to solve. I can factor this, so I'll factor out an x, and I've got x times x minus 5 equals 0. So using the factor theorem, either this thing is equal to 0 or this thing is equal to 0. The only way that this thing is equal to 0 is if x is equal to 0, or if x minus 5 is equal to 0, or in other words, if x equals 5. So we have two solutions. We have two solutions in this case. The first solution is x equals 0, and the other one is x equals 5. Now, let's check. Let's check our solutions here. So let's just check. Okay. So let's see here. If x is equal to 0, oh, and also we're actually not done here. So I suppose there is a fourth part of our procedure. So why don't we just scroll back here, and I'm going to add in one more part of the procedure, and then 4. So determine your y value to get an x, y ordered pair. Right? Because we're looking for a point of intersection. It's not just the x values, but it's the y value as well. So we're going to go back to, so our two solutions is x equals 0 and x equals 5. In this case, what's y going to be equal to? Well, let's choose one of our equations. Let's see. So let's do the linear equation, because that looks like it's easier to work with. So we're going to have this one here. So 2x minus y equals 4. So if 2x minus y equals 4, then well, we would have 2 times 0 minus y is equal to 4, or in other words, negative y equals 4, or y equals negative 4. Okay, so that would be our one point. So we would have the point 0, negative 4. Okay, and the other point of intersection, well, if x is equal to 5, we would have 2 times 5 minus y equals 4, right? I'm just figuring out what the corresponding y values would be. We would have 10 minus y equals 4. We would have negative y equals negative 6, or in other words, y equals positive 6. So our point would be 5, 6. Okay, so that would be the ordered pair that we're looking for. Okay. All right, no one's yelling at me on YouTube, so it looks like things are going okay. If you ever want me to slow down, or if I need to explain something a little more thoroughly or describe what I'm doing, I'm happy to do that. Oh, and of course you can't see what I'm doing here, so let me just scroll up a little bit. Okay, that looks better. So now let's check. Now we're going to check our work. So we should check our solutions. So check solutions. So we have two solutions to check. I've got 0, negative 4, and I've got 5 comma 6. So so let's go back to the original, and I'm just going to rewrite the equations again. So the one equation that I have, the one quadratic equation that I have is y equals x squared minus 3x minus 4, and the linear equation is 2x minus y equals 4. Okay, so let's try the first one. So let's try this one here, and we'll do it in both equations. So if y is equal to -4 and x is equal to 0, then let's plug those variables in. So if y is equal to -4, I've got -4 equals x squared. Well, x is 0, so I've got 0 squared minus 3 times 0 minus 4, and yet we've got -4 equals -4. That works. Okay, let's try the other one, 2x minus y, and it looks like I'm probably going to get cut off here again, so let me kind of zoom out a little bit. Okay, so I've got 2 times 0 minus -4 is equal to +4, or in other words, 4 is equal to 4. Yes, so this solution works in both equations. So we're good. We can accept that this first point, the 0, -4, is indeed a solution to both of the equations. So let's try 5 comma 6. Okay, I'll do this one in blue. So 5, 6 is going to be done in blue. So I would have, well, y in this case would be 6. So I've got 6 equals 5 squared minus 3 times 5 minus 4. Okay, well, 6 would be 25 minus 15 minus 4. Well, 25 minus 15 minus 4, that's like 25 minus 19, which is indeed 6. So 6 is equal to 6, and we're good. So it works in the quadratic. Let's try it in the linear equation. So we've got 2 times, what do I have? 2 times 5 minus 6 equals 4. So in other words, 10 minus 6 equals 4. And yes, 4 is indeed equal to 4. So yes, both of these solutions are valid, and they work in both equations. So let's see what this looks like on a graph. So I'm going to head over to Desmos really quick, and we'll punch this system in, and we'll see what that corresponds with in terms of our intersection points and that kind of thing. So let's try this out. Let's see here. Oh yeah. So I've got, the first one was y. Let's do the parabola first. X squared minus 3x minus 4. Okay, so that's this equation here. Okay, so that looks like just, a fairly general parabola, nothing too special about it. And apparently we've got 2 solutions here, so let's see what that looks like. Oops, so I'll go over here, and the other one was 2x minus y equals 4. Oops, equals 4. There we go. Okay, so yeah, it looks like we would have 2 solutions. And this solution right here is 0, -4, which I think we had, right? 0, -4, good. And this one over here is 5, 6. So yes, this graph is absolutely consistent with our solutions. So that was our procedure. We've got about 10 minutes of class. So what I'd like us to do is I'd like us to do one more equation, or one more system, and we'll do it together. So I'm going to give you 8 minutes to do it, and then I'll go over the solution very quickly. So I mean, if I can, we'll see how long it takes. So so your turn. So try this one. I'd like you to try. Okay, so I've got, y equals -1/2 x squared plus 2x minus 3. That's one of the equations. And y equals x minus 2. And I would like us to solve this system. Okay? So I'm going to get you to solve this system of equations. I'm going to give you 8 minutes. It's okay. I mean, if you don't finish it in 8 minutes, it's really not the end of the world. But I want you to give it a shot. if you're not entirely sure what to do, I would think about a procedure. So first of all, solve for y. That looks like that's already been done for us. Second of all, set each side of the equation that doesn't have y in it equal to each other. Okay, that shouldn't be too hard. The rest is to solve. Okay, 8 minutes starting now, and looks like that's going to take us right to 11 o'clock. So what I'll do is I'll actually just give you the solution, and you can work it out amongst yourself. Almost ready. 30 more seconds. Okay, look at that. Okay, so the long story short to this one is that there are no solutions. Sorry, guys, no solutions. I'm not going to go over the entire process. I will graph these two though. Oops, that's not what I wanted. That's what I wanted. So let's graph both of these equations and see what we get. Okay, so I'm going to just jump right into here. Okay. Oh, come on. What were they? Just give me one sec here, folks. There they are. Okay. Steal my mouse and keyboard from my computer, connect it to my iPad, so I have a better typing experience. And the equation was y equals negative 1/2 x was x squared. Well, negative 1/2 x squared plus 2x minus 3. Why is that? Okay, yikes. Holy smokes. Okay, yx squared plus 2x minus 3. Okay, that's that one. Y equals negative 1/2 x squared plus 2x minus 3. Great. The next one would be, what was that? Y equals x minus 2. Okay, so you can see that there is no intersection between these two. All right, and so that's the visual representation of it. The algebraic representation would be that, so if I have x minus 2 equals negative 1/2 x squared plus 2x minus 3, well, if I set this all equal to 0, so this would be negative 1/2 x squared, what was that going to be, plus x minus 1. I think that's about it. Yeah, minus, oh yeah, and if I want, I could make this all positive, so multiply both sides of the equation by negative 1, and I would get, although I don't even have to do that. Using the quadratic formula, this would be A, this would be B, just like a positive 1, and then this would be C, and let's take a look at the discriminant. So the discriminant would be b squared minus 4ac, and let's see what we would get. So I would get b squared, which is 1 squared, minus 4 times a, which is negative 1/2, times c, which is negative 1. So this gives me 1 minus, 4 times negative 1/2 times positive 1/2, it's like 4 times a positive 1/2, which is 2, so this is equal to negative 1. So the discriminant is negative, and negative discriminant means that there are no solutions. So there you have it. No solutions to this equation. So your exit slip today is going to be to solve the following system. Give me 1 second here. Your exit slip is to solve the following system. Okay, that one's too gross. Yeah, we'll do this one. Okay, so exit slip. To solve this system, I've got x squared minus y equals 0. That's 1. The next one is x squared minus 2x plus y equals 4. Okay, so that's your system. I want you to solve it algebraically. Yeah, that's what you got to do today. If you're not sure how to do this, please submit the exit slip anyways. I really would like to know if you are not able to do this, or if you're struggling with this. There's no shame, but your teacher's got to know, right? That's my profession, to know what my students can and can't do. So if you can't do this, don't just pretend that you didn't watch the live stream and just sort of ghost me. No, let me know, and I'll help you out. So yeah, that's what I want you to do. As for homework, homework, and I really wish I had updated the website on Friday, but your homework is systems. Oh wait, no, shoot, I gave you the wrong stuff again. Okay, oh my goodness, what a disaster. Your homework's going to be on the website. Systems of equations. Okay, so I'm going to put that on the website very shortly. Sorry, I'm a bit of a scatterbrain right now. Not really sure what's going on. But your homework is on systems of equations, and this will be on the website very shortly. And this is just going to be linear equations. So I'll say systems of linear equations. Sorry about that. We've got systems of linear equations. That'll be on the website. So yeah, stay tuned to the website. Check out the homework assignment on radicals on Google Classroom. And yeah, I'll talk to you guys tomorrow. Okay, bye-bye.